Hey everyone, so I'm going to go through how to do a couple of these gas law problems, and let's go and kind of review for a second though. It's going to give you some units, and it's going to give you some numbers, and then you have to pick out which gas law you should use, which says right here, and then which of the formulas you should use. So I posted a gas laws flowchart. It looks like this. It kind of got cut off over here a little bit. But it'll tell you which variables you have and then which ones that you need to use, which formula you need to use and that kind of thing. Alright, so kind of to review a little bit, MMHG, ATM, PSI, TOR, and KPA, they're all pressure units. Alright, so there's 5 different ones. MMHG stands for millimeters of mercury, ATM is atmospheres, PSI is pounds per square inch, which is like what you would find in your tire. TOR is the same thing as millimeters of mercury, and KPA stands for kilopascals. Alright, so then, if it says ml or L, so ml is milliliters, L is liters, both of those are volume. Alright, so now it says, let's do this first one. It says the volume of a gas is 230 milliliters at 2.25 atmospheres ATM. Alright, so this first question asks you, it says, is 230 milliliters ml a pressure, volume, temperature, or amount of gas? Amount of gas is going to be moles, and I don't think there are any problems like that on here. Alright, so milliliters is going to be a volume. So I'm going to put volume here in this box. Alright, 2.25 atmospheres, an abbreviated ATM. So ATM is here, so it's going to be a pressure. So it's going to be volume and pressure. Alright, next one, 560 milliliters. That is a volume again, because ml or L are both volumes. So liters, you've probably, bought a 2-liter soda or something like that at the grocery store. So now we've got volume and pressure. And we're going to look at this flow chart and say, okay, which one should I use? So here's pressure and volume. Kind of got cut off. I don't know why. Alright, so it's going to be Boyle's law, and it's going to be P1 V1 equals P2 V2. Alright, so which gas law should I use? I'm going to use Boyle's. And the formula I'm going to use is P1 V1 equals P2 V2. Alright, so now I'm going to fill in these boxes down here. P1 V1, P2, V2. Alright, and I set it up this way because they're multiplied together, so I just did P1 and then V1, P2 and then V2. Alright, the first volume that it gives me is 230 milliliters. So I'm going to fill that in for V1. So 230 milliliters goes there. Alright, 2.25 atmospheres is a pressure, so I'm going to put that here, 2.25 ATM, or atmospheres. Alright, the next one it says is 560 milliliters. So that's going to be my V2. So 560 ml goes there. Alright, and you may be curious, you may be saying, okay, well how do I know that these two go together for P1 and V1? If they're in the same sentence together, they're most likely going to go together. So if you read the sentence up here, the volume of a gas is 230 milliliters at 2.25 atmospheres ATM. That's my dog. He's behind me. So P2 is going to be equal to X. Alright, so now I'm going to plug these into this formula here. So 2.25 times 230 equals X times 560. So remember, those little dots here, that means multiplication. So 2.25 times 230, and I've got my fancy calculator. You can probably just use your phone if you'd like. Alright, so 2.25 times 230. Alright, 517.5 equals 560 times X. Alright, so since this is multiplication here, I'm going to divide by the 560 to get X by itself. Alright, so now I'm going to do 517.5 divided by 560. So 517.5 divided by 560. Alright, and that gives me 0.924. So 0.924 equals X. Alright, so now you have to ask yourself, what should the units be? Alright, and remember the units for both of the pressures have to match, so since this is ATM, this also has to be ATM. So now you can fill that in up here into this box. Alright, so there you go. That was pretty easy. Alright, so let's move on and let's do number 2. So remember, if you need me to go slower, or you need something, you missed something, you can always pause this video, go back to the beginning, and keep going. Alright, so let's do number 2. And my sheet may look a little different than yours because I added more space so I can actually work out these problems. Alright, so it says if the volume of a gas is 958 milliliters at 75 degrees Celsius, at what temperature would the volume of the gas decrease to 822 milliliters? Alright, so the first question says, is 958 milliliters a pressure, volume, temperature, or amount of gas? So remember, ml or L, those are going to be volumes. And then we've got mmHg, ATM, PSI, torr, and then kPa. Those are all pressures. Alright, so 958 milliliters, that's going to be a volume. Alright, 75 degrees Celsius, is that a pressure, volume, temperature, or amount of gas? So since it says degrees Celsius, we know that that is a temperature. But you got to watch out because we can't use degrees Celsius in these gas law equations. We're going to have to convert this into Kelvin, which is actually pretty easy. You just add 273, and down here at the bottom it tells you, it reminds you. Alright, so now 822 milliliters, that is going to be a volume, because if it's ml or L, it's going to be a volume. So I'm going to put volume here. Alright, which gas law should I use? Alright, so we've got volume and temperature, and it looks like, what are we given? Volume and temperature, Charles's law, and we're going to use this formula down here. Alright, so which gas law should I use? I'm going to use Charles. And what formula should I use? Alright, so it's going to be V1 over T1 equals V2 over T2. Alright, and we're going to cross multiply to solve this. So let's fill in these blanks down here. So V1 here, T1 here, V2 here, T2 here. So you may be asking, well, why did you put it this way? I just put it this way because that's the way the formula is set up in these boxes. So it kind of looks like the formula over here. Alright, so the first volume that I encountered in this first sentence up here, the volume of the gas is 958 milliliters. So I'm going to put 958 milliliters there for the first volume. Alright, the next one says it's 75 degrees Celsius. So 75 degrees Celsius. But remember, we can't use degrees Celsius in the gas law equation. So we're going to have to add this magic number, this 273, to get it into Kelvin. Alright, so I'm going to take out my calculator, and I'm going to do 75 plus 273 equals 348. So that's going to be 348 Kelvin. Alright, V2. In the next part of this up here, it says, at what temperature would the volume of the gas decrease to 822 milliliters? So it says, at what temperature up here? The temperature 2 is going to be the X. And then 822 milliliters, you told me it was a volume, so it's going to be V2. So it's going to go here, 822 milliliters. Alright, so since we don't know the T2 is X, whenever we get it out of the equation, it'll automatically be in Kelvin. So we don't have to add 273 to it, or subtract 273, or anything like that. Alright, so now let's plug this into this formula up here. So V1 is going to be 958. We're going to put it over the Kelvin temperature, which is 348, equals 822 over X. Alright, so I just plug these into this equation up here. Alright, so 958 over 348 equals 822 over X. Alright, to solve this, you're just going to cross multiply. So we're going to do 958 times X. So remember, this little dot means X, equals 348 times 822. Alright, so 958 times X is just going to be 958X equals, and then in my calculator I'm going to do 348 times 822, and that's going to give me 286,056. Alright, so now this is just algebra, So 958 times x equals this. We want to get the x by itself. So since this is multiplication, I'm going to divide, which is the opposite, by 958. So whatever we do on this side, we also have to do to this side. So now we're going to have to do 286056 divided by 958. And that is going to give me 298.597. So 298.6. So x equals 298.6. And it's going to be in Kelvin. Alright, so now you can take this number, fill it back in up here, equals 298.6 Kelvin. Alright, so what this is saying is it's saying that they took the volume is 958, and that temperature was 348 Kelvin. When they decreased the volume, the 822, the temperature actually went down. It went from 348 to 298. Alright, so it basically went down from 75 degrees Celsius, and this is about 25 degrees Celsius. Alright, so let's move on to the next one. And remember, if you're, you get a little behind or something, or you get distracted, click pause and then rewatch some part of this video. Alright, so let's do the next one here. And this one has a lot of information in it. Alright, so it says the volume of a gas is 1.15 liters at 760 millimeters of mercury and 0 degrees Celsius. So it's given us liters, millimeters of mercury, and degrees Celsius. So it looks like it's given us 3 pieces of information, so we'll probably have to use the combined gas law. Alright, so 1.15 liters is at a pressure, volume, temperature, amount of gas. It's going to be a volume. So remember, ml or L equals a volume. Alright, 760 millimeters of mercury, mmHg, that's definitely going to be a pressure. And then 0 degrees Celsius is that a pressure, volume, temperature, or amount of gas. That's going to be a temperature, because it says degrees Celsius, right? Degrees. And remember, we'll have to add 273 to the 0 to get the Kelvin temperature here in a second. Alright, 1.56 liters, that's definitely going to be a volume again, because milliliters or liters is a volume. And then 650 mmHg is that a pressure, volume, temperature, or amount of gas. Pressure. Alright, so it looks like we've got volume, pressure, and temperature. So if we look on the gas laws flowchart, which is right here, it says we've got pressure, volume, and temperature. The combined gas law is the one that has all 3. If we had moles, we would use the ideal gas law, but we haven't really discussed ideal gas law yet, so we're not going to do that. Alright, so the combined gas law is going to be the gas law that I should use. Alright, so combined gas law. Alright, and the formula is going to be P1 V1 over T1 equals P2 V2 over T2. Alright, so in this one we have 6 pieces of information, and we need 5 out of the 6 things to solve it. Alright, so let's fill in this chart down here. So P1 V1 T1, P2 V2, and T2. Alright, so P1, that was the first pressure that we encountered. And if you look at your chart up here, the first pressure that we encountered was the 760 millimeters of mercury, or the mmHg. So it's going to go 760 mmHg there. Alright, the first volume that we encountered was the 1.15 liters. Alright, and a lot of you ask me, you say, well, how do you know that these numbers go together? They are all in the same sentence up here. So the volume of the gas is 1.15, 760 millimeters of mercury, and 0 degrees Celsius. So if they're in the same sentence together, they go together. Alright, so now for T1, we've got 0 degrees Celsius, but we're going to have to add the magic number, 273, 20. So it's going to be 273 Kelvin. I almost ran out of space there. Alright, so now the P2, the second pressure, if you look up here, it says, at what temperature would the volume of the gas increase to 1.56 liters if the pressure decreases to 650 millimeters of mercury? So P2 is going to be the 650 mmHg, or the millimeters of mercury. Alright, the V2 is the second volume that we encounter, and 1.56 liters looks like that one. So remember, milliliters or liters is going to be your volume. And then if you read the question again, it says at what temperature. So T2 is going to be this X. Alright, so remember, if the temperature is the X, it's automatically going to come out in Kelvin, and you don't have to add 273 or subtract 273 or anything like that. Alright, so I'm going to plug these into this formula up here. So 760 times the V1, which is 1.15, divided by the Kelvin temperature, which is 273. Alright, on the other side over here, we've got the P2, which is 650, times the 1.56, divided by this X. So it's the unknown. Alright, so how can we solve this? It's easy. We're just going to cross multiply again like we've always been doing. Alright, so 760 times 1.15 times X, because I just took this times this times this, equals 273 times 650 times 1.56. So I'm just cross multiplying and setting them equal to each other. So 273 times this. Alright, so now on the left side of this equation, I'm just going to put in my calculator, I'm going to put 760 times 1.15. Alright, and that gets me 874. But remember, you've still got this X over here. So 874 times X is going to be equal to, and I'm going to multiply all three of these together over here. So 273 times 650 times 1.56, and I got 276,822. So I'm going to put that here, 276,822. Alright, so now to get this X by itself, this is multiplication. I'm going to do the opposite of that. So I'm going to divide, and whatever I do to one side I have to do to the other side. So this is going to go away and it will just leave us with X. Alright, so now on my calculator I'm going to do 276,822 divided by 874 equals 316.73, and it's going to be in Kelvin. Right, so there you go for that one. Alright, so X equals 316.73 Kelvin. Alright, so now we've solved that one. Alright, so what it's saying is it's saying if I decrease the pressure and I increase the volume, then the temperature is actually going to go up. It's going to go from 273 to 316. And if you want to find out what temperature this is in Celsius, you could just do 316.73 minus the 273. And it looks like it's about 43.73, and that's actually pretty hot. It's going to be, I would say, close to 100, or a little bit over 100 degrees Fahrenheit. Alright, so if we move on to number 4, alright, number 4 is giving us three things. Alright, so it says, is 110 kPa pressure, volume, temperature, or amount of gas? Remember, kPa, let me slide this down, kPa, mmHg, torr, psi, and atm. Those are all pressures. Alright, so now it's giving us 110 kPa. So since it's kPa, kPa is going to be a pressure. Alright, and it gave us degrees Celsius for this one. So 75 degrees Celsius has got to be a temperature. And then 100 degrees Celsius, again, that's another temperature. Alright, so which gas law should you use? So let's take out this handy flow chart. And the flow chart says that if we have pressure and temperature, we are going to use Gay-Lussac's law, which is P1 over T1 equals P2 over T2. Alright, so it says which gas law should we use? We're going to use Gay-Lussac's. And the formula is going to be P1 over T1 equals P2 over T2. Alright, so now let's fill in this chart down here. P1 is going to go in this first blank here. T1 is going to go here. P2 goes here. And T2 goes here. Alright, for the first one, the first pressure is going to be 110 kPa. Alright, T1 is the first temperature that we encounter, and how do I know that these two go together? They're in the same sentence up here. So if a gas is a pressure of 110 kPa at 75 degrees Celsius, so So 75 degrees Celsius is going to go here. But remember, we got to add that magic number 273 to it to get it into Kelvin. Alright, so 75 plus 273, that is going to be 348, and that's in Kelvin. Alright, it says up here, what would the new pressure be? Alright, so P2 is going to be your X. It's going to be your unknown. Alright, the next temperature that we have is 100 degrees Celsius. So 100 degrees Celsius goes here. And we're going to add 273 to it. Because remember, to get from Celsius to Kelvin, we have to add this 273. So we're going to do 100 plus 273. That is going to get me 373. Alright, and now all I have to do is I have to plug it into the formula that I have here. So I'm going to do 110 kPa over the T1, which was 348. Remember, you have to use the Kelvin temperature. You can't use the Celsius one. It's going to be equal to X over 373. And again, you don't need the units. I don't know why I did that. Alright, to solve this, cross multiply. So we're going to do 110 times 373 equals 348 times X. Alright, so these parentheses just mean the exact same thing. It's multiplication. Alright, so we've got 110 times 373. So on my calculator, I'm going to do 110 times 373. And I got 41030, so 41,030 is equal to 348 times X. Alright, and since this is multiplication, we're going to divide. We're going to do the opposite to get the X by itself. And whatever I do on one side, I have to do it on the other side. So we're going to do 41030, so 41,030 divided by 348. And that is going to get me 117.90 equals X. Alright, so now you may be thinking, okay, well, what unit is this in? Remember, since it's P2, this has to match this in units. So whatever this is, this one has to be as well. So it's going to be 117.90 kPa, or kilopascals. Alright, so now you can fill that in up here, 117.90 kPa, and you're done with that one as well. Alright, so now we've got this one more to do, number 5. Alright, so I think on yours, on number 4 and 5, I've put 6 blanks on here, but you only need the 4 blanks. I think I copied and pasted and I got it wrong. Alright, so now number 5, it says I have a gas that takes up 345 milliliters. Alright, so milliliters or liters has to be a volume, right? Alright, so now it says 345 milliliters, that's got to be a volume. Alright, 23 degrees Celsius, is that a pressure, volume, temperature, or amount of gas? So since it says degrees Celsius, that's got to be a temperature, so I'm going to write temperature here. Alright, 760 milliliters, is that a pressure, volume, temperature, or amount of gas? Milliliters has got to be a volume. Alright, so now if we look at our handy dandy flow chart, it says what are you given? We are given volume and temperature. So pressure and volume, no. Volume and temperature, there it is. So we're going to do Charles's law. Okay, what formula should I use? So then if you look back at the flow chart again, down here, V1 over T1 equals V2 over T2. So V1 over T1 equals V2 over T2. Alright, and now we're just going to plug in these. So V1, T1, V2, T2. Alright, so now let's read the problem again and let's see where we can fit all of these in. I have a gas that takes up 345 milliliters, and you told me that the 345 milliliters is a volume. So 345 milliliters goes here. Alright, 23 degrees Celsius. You told me that's a temperature, and since they're in the same sentence together up here, the same part of the sentence together, you're going to plug that in for the T1. So it's going to be 23 degrees Celsius. But remember, we got to add that magic number, that 273, to the temperature. So 23 plus 273, that's going to be 296. Alright, and finally V2, the second volume, is going to be 760 milliliters. Alright, so 760 ml. Alright, and the T2, it says, what is the new temperature? So new temperature is what we don't know. That's going to be X. Alright, so now all we have to do is we just plug these in. Alright, so it's going to be 345, because that's the V1, over the T1, which is this 296. Set it equal to V2, which is 760, over X. Alright, to solve this, we're just going to cross multiply here. Alright, so we're going to do 345 times X. So remember the little dot means X, or I'm sorry, it means multiplication. Alright, and then we're going to do 296 times 760. Alright, so now on this side, we're just going to have 345x, because anything, you can't really merge those together. Alright, on this side, on the right side, we're going to multiply 296 times 760. Alright, and I got 224,960, so 224,960. Alright, now to solve this, we want to get x by itself. So since this is multiplication, we're going to do the opposite of multiplication, which is division. So I'm going to divide by 345. And what do I do to one side, I have to do to the other side. 345 divided by 345 is just 1. So we're just left with x. So 224,960 divided by 345. That is going to give me 652.057,971. I'm just going to round it to 0.6. Alright, now you may be asking yourself, well, what unit is this? Remember, these two have to match, so this is 296 Kelvin. So this new temperature also has to be in Kelvin. So this is going to be 652.06 Kelvin. Alright, and that's pretty much it. If you have any questions, please let me know. Watch the rest of this video if you have trouble. And, of course, you can send me an email, or you can comment on Google Classroom, or give me a call. The number's 864-355-2830. Thanks. Have a great day.